All right, so we're going to look at how you're going to complete this virtual collision theory lab. What you're going to do is you're going to pull this up, and up here there is a link. That link is going to bring you to this web page right here. I want to point out a few things. Underneath this black box that I used, because I used a different screen recorder to show you how to do this, there's a thing that says A, and it's going to show you a green dot. B, they're going to show you a blue dot, and P, which is going to be a red dot. I want to make note of that. That means A and B are your reactants, and P is your product that you're going to be forming. So let's just watch what I did here, and then you can see as we go along how it works. So let's play this. All right, when you click on your virtual collision lab, what you're going to see is this blank blue screen. And on the right here, you have all of these different variables. A is a green circle, and you can see that down here. B is a blue circle, and P is a red circle, P representing the products. When you set it up, the defaults are going to be correct for your experiment number 1. I want you to have A set at 20, B set at 20, P product set at 20. I want you to have your temperature at 20 and your volume at 400. And then you're going to come over here and you're going to hit setup, so it will highlight in red. You're going to click that. And when you do, all these green dots, which are reactant A and reactant B, there should be 20 of them. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you should have 20 green ones and 20 blue ones. And you can see on your lab, I recorded in that column 20 A's and 20 B's and 0 P's. There's no red dots here on this screen. When you hit start, the timer is going to start increasing. I want you to hit start and watch that timer until it gets to 10 seconds. So down here, it's counting for you till 10 seconds. So we'll just wait those 10 seconds, and then I'm going to hit stop when it hits 10 seconds. Now you're going to record how many green dots you have left on your screen and how many blue dots you have left on your screen, and then how many red dots were formed in that reaction. So basically what happened was the green and the blue reacted to form the red. So the green is disappearing, the blue is disappearing, and the red is appearing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 green ones. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 blue ones. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 red ones. So that would be your second row where it says 10 seconds. You're going to continue that by starting this again. We're going to go up to 20 seconds. So we'll just wait until this goes up to 20 seconds. We will hit stop when it gets to 20 seconds. And we'll count again. So now we have 4, 5, 6, 7 green ones. We have 1, 2, 3, 4, 5, 6, 7 blue ones. And then you can count the red ones. You're going to record those all. And then we're going to graph this reaction. When you're ready to do your graph and you have collected all of your data, you're going to graph the number of green particles, which was your reactants. You had 2 different reactants, but you only have to graph 1. And you're going to do the number of products versus, on the x-axis, time in seconds. So what we'll do is we'll do 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60 seconds. Okay, and so you'll look at your numbers. At 0 seconds, you had 20, 20, and 0. So we need numbers here. 10, 20, we need... So I figured out that I would go up by 2s. At 0 seconds, I had, for green, because that was my reactant, I had 20. And for my product, which was in red, I had 0. At 10 seconds, I had 9 green ones. So I gotta go back to my green pen. I had 9 I had 9 green ones and I had 11 red ones. So I'll graph 11. Okay. And then at time 20 seconds, I had 7 green ones. So I'll put it 7 green ones and 13 red ones. Get a red pen out. 13 red ones. So 13's right around here. Okay, so you can start to see that your green line, let's get a green pen again, your green line is going to go like this, and your red line is going to go like this. Okay, so that's for experiment 1. And then you're going to change different variables for experiment 2, 3, and 4, and you're going to fill in those charts. For experiment number 2, you're going to change the temperature. And by that, I mean what you're going to do is you're going to reset your animation. You're going to keep A and B set to 20. So you're going to have 20 green ones and 20 blue ones. You're going to have no red ones when you start. But this time we're changing the temperature setting to 100. Keep the volume the same at 400. Click Setup. Okay, so everything gets set. And then you're going to do the same by filling in these numbers down here and graphing them. And this time on your graph, I'm not going to go and grab it, but you're going to have the same thing. You're going to have time down here. That's going to be in seconds. And you're going to have a green line. That's going to be your A. And you're going to have a red line. That's going to be your P. So your green line should be going down, something like this. I don't know what the curve's going to look like. And then your red line should be going up, like that. But it's not going to go up at the same rate because we're changing our temperature now. Okay, so we're looking at what's going to happen to the rate of the reaction as we change the temperature. For your third reaction, you're going to change the concentration. So return, click Setup to reset the animation, right? Click Setup. Return the temperature to 20. We don't want to change temperature this time. This time we're going to change the volume, or make sure the volume set to 400. Change the number of particles, A particles, to 40. So that's going to change the concentration because now I'm going to start with 40 green ones. Keep B, which is the blue ones, at 20. So we have more particles now. And we're going to click Setup, and we're going to start it again and record our numbers. And this time we're going to plot the graph exactly the same way. So the red should be, the green should be coming down, and the red should be going up, just in a different rate. And then finally, the last one, you're going to change the volume. And that one, you change the volume to 300. You should be getting the hang of this at this point. A and B back to 20 each, so 20 green, 20 blue. You're going to change the volume to 300, make sure the temperature's at 20, and then you're going to record your numbers. And you're going to plot your curves. Your red should be going up, and your green should be coming down. Okay? When you're all done with collecting your data, you have a bunch of questions here that you're going to answer. Okay? So look at your graph for the first experiment. During which 10-second interval, like from 0 to 10 seconds, from 10 to 20 seconds, 20 to 30 seconds, which interval was the rate of the reaction the fastest? So look where the slope is the greatest, right? We're looking for the biggest change. Explain why the rate of the chemical reaction changed as time proceeded. Why did the graph look like this? Whoops. Come on, red pen. Where are you? Stop moving my paper. Okay? Why did it do that? Why did it start to flatten out? What did you start to run out of? Okay? Look at the amount of green that you have. Green coming down. Okay, you're getting less and less green. So why would you start to level off in the amount of product that you can make? In experiment 2, we looked at the effect of the temperature on the rate. How did the rate of the reaction change when the temperature increased? So we increased the temperature. What happened to the rate of the reaction? Did it get faster? Did it get slower? Then, let me pull this up a little bit. Oh, maybe I can't do that. Hold on, let me erase this. All right, what do you think would happen if you decrease the temperature? Would the reaction get faster or the reaction get slower? Moving on to 3, or question 3 here. Experiment 3, we're looking at the concentration. So we added more stuff into the beaker, like more green, right? There were more green. There were 40. I think we upped it to 40. The effect of the concentration on the rate of the reaction. So as we up the concentration, what happened to the rate of the reaction? If the temperature was as low as 20, why did the data table stop at 40 seconds? What did you run out of? Look at your reactants. Do you have any left? What do you predict would happen to the rate of the reaction if the number of B particles was also set to 40? If you're curious, go ahead, go back to the animation and check it out. If you had 40 green and 40 blue, what would happen to the rate of the reaction? And then would you predict would happen to the rate of the reaction if the number of A particles was reduced to 10? Would they collide more? Would they collide less? Okay, and I think that's it. Nope, that's not it. We got to go to the next page. Okay. Experiment number 4 looked at the pressure of the reaction. It was for a gas only. We increased the pressure. How did the rate of the reaction change when the volume was decreased to 300? So by decreasing the volume of the container, like at first we started with a container that was 400, then we went to a container that was 300. So the volume decreased. When the volume decreased, what happened to the pressure inside that container? It increased. So we are looking at the effect of the pressure. How did the rate of the chemical reaction change when the volume was decreased to 300? Did it get faster? Did it get slower? So check that out. How does lowering the volume change the pressure on the gas? When I lowered the volume, what happened to the pressure inside that container? I'm getting better at this, right? I was able to erase that without having to pause you. Okay, and then finally, the rate of the chemical reaction depends on the number of effective collisions. And we looked at that in the video from yesterday. What experimental conditions, we just looked at a bunch of them, increase the number of collisions between reactant particles? What things can we do to increase the number of collisions between reactant particles? Okay, I hope this video helped you out.